Chapter 5.1, the natural logarithmic function differentiation. Day 1, a review of logarithmic properties. We are starting transcendental functions this chapter, meaning functions that aren't polynomials or rationals. They're going to have a little bit different. There's not going to be a to the x a lot. It's going to be a little bit more trig. All right? Remember the power rule for antiderivatives? Power rule for antiderivatives said you had to add 1 to your power and then divide by that new power. However, if our power is -1, aka we start with 1 over x, if you add 1 to -1, you get 0. And then divide by 0 doesn't work. So we need a new way to do that one instance. And that new way is we define the antiderivative of 1 over t dt to be the natural log of t, or the area under 1 over t from 1 to x is the natural log of x. This is our definition of the natural log. All right? Some properties of natural log. Its domain is anything positive, from 0 to infinity, not including 0. So you can't have a negative number and take the natural log of it. So consequently, a lot of times when we do our natural log antiderivatives, we'll have the natural log of the absolute value. All right? The range, you can get any number as an answer. It's continuous, increasing, and 1-to-1. 1-to-1 means it has an inverse. And it's always concave down. All right? You should remember from your pre-calc days what it looks like. Graph of the natural log looks like this. You can see your domain, you can see your range, you can see the concavity, and you can see it's always increasing from that graph. And then 1-to-1, that refers to the vertical line test. It also refers to a horizontal line test, meaning all of those cross the graph exactly once. All right, some properties you need to know. You need to know the natural log of 1 is 0. I'm going to even include, you need to know that the natural log of e is 1. You need to know that when you have a multiplication in the log, you can split it to addition of the logs. Very important for taking derivatives, that you can be able to split it. You need to know the power rule of logs. Anytime there's a power in there, you can bring it out front and multiply it. And then division of logs is subtraction of the logs. This is kind of like the opposite of number 2. Multiplication and division are opposites, therefore addition and subtraction are opposites. And then again, these are all reviews from your pre-calc days. You should know these properties. Let's just practice them. Here we got the natural log of 10 ninth. We want to rewrite that. Since it's a division, we want to split that. The natural log of 10 minus the natural log of 9. Seems like a little thing, but when doing derivatives, it makes it a million times easier. All right. Here we have the natural log of the square root of 3x plus 2. The natural log of, well, let's rewrite the square root as the 1/2 power. And then because it's a power, we can bring it out front. 1/2 the natural log of 3x plus 2. Here, it's a division. So we can split that to subtraction, natural log of 6x minus natural log of 5. Now, 6x, that's multiplication. So we can split that, the natural log of 6, plus the natural log of x, minus the natural log of 5. And if you saw that right away, you could have gone straight to there instead of doing it in 2 steps. All right? Now this one is kind of long. We're going to split it with the division. Now notice there's 2 things on the bottom of the division. what you could do, there's two ways you can look at it. You can look at it as, oh, I need to subtract this, and those are being multiplied, so I can add those. But remember to keep those grouped because they're on the bottom together. What I like to do is, they're both being divided, so what I like to do is I like to just subtract them both. So I'll do natural log of x squared plus 3 squared minus the natural log of x. This is also being divided. So you're going to minus the natural log of the square root of x squared plus 1. Now, like I said, you could think of it as they're being multiplied on the bottom, but then you'd have to group them because they're together on the bottom. But you're going to end up having negative anyway as you distribute the subtraction. So why not just go straight to the subtraction with the fact that they're both being divided. Let's deal with the powers now. So bring the 2 out. Minus the natural log of x. And then again, the square root is the 1/2 power, so bring the 1/2 out. Don't split this, because that's addition, and this power is not the whole thing on the whole thing, so don't bring that power out. Only bring the power out front if it's on the entire term. All right, so in review, the properties you need to know. The natural log of 1 equals 0. The natural log of e equals 1. You need to be able to split addition. You need to be able to split the multiplication within the log to addition of the logs. You need to be able to split division in the logs to subtraction of the logs. And whenever there's a power on something that's inside the log, bring that out.